All right, partial fraction decomposition. First thing you want to make sure of when you go to do partial fraction composition is make sure the fraction is quote unquote proper. What's that mean? We're dealing with polynomial fractions here, so what that means is the degree of the numerator is less than the degree of the denominator. That's what that means, okay? Nothing more than that, okay? And if it's not, say you had an x to the fourth power on top and an x squared on the bottom, you need to do long division to fix that. Okay, and if you do long division, what it does, you're going to get a polynomial that's your quotient, and then you'll get the remainder that's a fraction. And it really, what it ends up giving you is a much smaller fraction to decompose. So the long division, yeah, we've done that before, so that shouldn't be anything that should be too daunting. But you want to make sure that you got a proper fraction, and that long division is how you get there if you need to do that. Most of the time, you're not going to need to do that. Okay, there's only a few times that you'll have to do that. Okay, we'll look at some and how this. All right, so I think the best way to learn how to do this is just do some problems with it. We could talk theory all day. I don't know if that's going to make much sense. Just get concrete with it and actually do a problem with it and step by step through it and see if I can get you the process going. So example A, we're going to decompose 5x minus 1 over x squared plus x minus 12. Okay. So we're going to decompose that fraction. So the thing we got to do first, the very first thing you should always do is factor the denominator. Okay, so we've got the degree of the top is 1, the degree of the denominator is 2, so we don't have to do long division there. The next thing we're going to do is try to factor the denominator as far as you can, okay, completely, okay. So that's a trinomial, so it's pretty easy to factor. What are the factors that go with that particular? 4 and negative 3, so it'd be x plus 4 and x minus 3. The numerator is not changing. Okay, we're not changing the numerator at this point. Okay, once you've got the denominator factored, then you can build what's called the decomposition template. And the decomposition template is key. If you don't do the decomposition template correctly, you're going to not be able to get the right answer with the actual decomposition of it. So when you build your decomposition template, it stems on factoring that denominator correctly, okay, and completely. All right. So that's factored correctly and completely. So when you build your decomposition template, the template for this one is splitting that denominator up into a fraction for each factor. Okay, so we've got the x plus 4 in the bottom, and then we get a fraction with the x minus 3 in the bottom. The numerator is dependent upon what kind of factor that is. Well, this is a degree 1. Right? X plus 4's got degree 1. The numerator should have 1 degree less than that. So 1 degree less than 1 is 0. So a degree of 0 is just a plain number. We're going to use capital A as that plain number here. The degree of the second denominator is 1. So 1 less than that's a plain number with a degree of 0. So then we're going to use the capital letter B to get that decomposition template. As we build up through this, we'll get to the bigger denominators that maybe have a degree 2. What's that do to the numerator and all that stuff? We'll see that as we go along. But the key to remember is that on your decomposition template, the numerator that you put in there is going to be variables, and its degree is 1 less than each denominator. 1 less, okay? All right, so there's our decomposition template for this problem. Once we've got that set up, the next thing we want to do is multiply out the missing pieces of the common denominator. The great thing is you don't have to struggle to find a common denominator here. You already have it up there in the original problem where you factored the denominator. You know that it should be x plus 4 times x minus 3. So what's missing from the first fraction? The x minus 3. So you're going to multiply a, the numerator, times the x minus 3, because its denominator didn't have that. The b is going to get multiplied by x plus 4, because that's the missing piece for its denominator. We're not worried about the denominators right now. We're worried about getting those numerators figured out, because that's where the missing, the variables are, is in the numerators. So you're going to multiply that out. It'll be ax minus 3a plus bx plus 4b. Now, the next thing is setting up your system of equations to find out what a and b are. Okay, so step 4 is set up the system of equations. And this is where I always list the numerator. The original numerator was 5x minus 1. Okay. What that tells me is that everything that's got an x in this red line right here, everything that's got an x should add up to be what? 5, because that's what's on the x there. So ax plus bx should be equal to 5. Okay, so our system for that part would be a plus b equals 5. So that's an equation for the x's. Then you've got plain pieces here. You've got a negative 3a and a positive 4b. Those are just numbers. Well, the just plain numbers in our numerator was minus 1. So negative 3a, so the numbers equation is negative 3a plus 4b equals negative 1. We have a system of equations. 2 variables, 2 equations. How can we solve that system? How have we done it so far this chapter? But do a matrix. That'd be one very good way to do that. So put that into a matrix. What would your matrix be? And then you would do RREF. That's absolutely right. So I would have the matrix 1, 1, 5, negative 3, 4, negative 1. And I would run RREF for that. Okay. Second matrix. It's a 2 by 3. 1, 1, 5, negative 3, 4, negative 1. RREF for that matrix. Get A is 3, B is 2, right? Is that what y'all got? No, we all got the right thing there. So with our REF, we get A equals how much? 3, and B is 2. So the decomposition of that fraction is we go back to our decomposition template, A over x plus 4 plus B over x plus or x minus 3, and we just rewrite that. So the decomposition is 3 over x plus 4 plus 2 over x minus 3. That's our decomposed fraction. That's what that is that we found. If you were to take this and do common denominator with it and add it back together, you get the original one back. The original problem at the beginning that had the x squared plus x minus 12 as the denominator. Okay. It's a pretty simple example, but it's the first one, so I didn't want to get too complicated on the first one. All right. Let's do another. Example B. Let's start with this one. X over x squared minus 5x plus 6. So the numerator is not going to change. The degree of the numerator is 1. The degree of the denominator is 2. So I don't have to do any long division on this one. So I want to do what first? X minus 2 and x minus 3, which is the factored form of that denominator. And factor in the denominator first. Then our decomposition template for that would be what? It technically does not matter which one you call A and B as far as which one's over x minus 2. You know, I wrote it x minus 2 times x minus 3. If you wrote it x minus 3 first and x minus 2 second, that's fine. It doesn't matter. You know, what you're going to look for is what number is over the top of the x minus 2, what number is over the top of that. So it's not a, you don't have to do it in a certain order to make it work. Okay. Now, from there, what's missing for the A? X minus 3. So we got A parentheses x minus 3. B is missing the x minus 2. So we're going to multiply that out. Get AX minus 3A plus BX minus 2B. And that creates a system of equations where A plus B is equal to what? 1. Because that's the coefficient on x in our numerator. And then negative 3A minus 2B is equal to what? What's the plain number in the numerator? 0. There's not 1, so it's 0. So we get that system of equations to solve. So solve that system of equations. You can use a matrix if you want to. The numerator up here doesn't have a plain number, so technically that's like adding 0 is what that's like. If there were a plus 8 there, it'd be equal to 8. But since there's nothing there, it's equal to 0. That's where it's coming from. So multiply by 3. So I got B equals 3, A equals negative 2. So our decomposed fraction would be negative 2 over x minus 2 plus 3 over x minus 3. Or written in the other order, 3 over x minus 3 plus negative 2 over x minus 2. Depending on what order you started with. There's our decomposed fraction. It's not too bad so far.
When it comes to bigger problems, there are more steps.
Well, yes, and we're about to make our problems bigger. So let's look at one where it is bigger. Example C. So let's say we had 3x minus 5 on the numerator, and in the denominator we had x cubed minus 1. X cubed minus 1. So factor in the denominator. You know, degree stuff is fine on this one again. So that's a difference of cubes. So we got to know how to factor that. Be x minus 1, x squared plus x plus 1. Right? Should know how to factor a difference of cubes. And then, so that trinomial over there on the right doesn't factor any further. If you do the x method, it doesn't work, okay? So that creates us two factors on the denominator. So our decomposition template is going to have a over x minus 1. That's 1 degree less, plain number. Now the denominator on the second one is x squared plus x plus 1. It's got a degree of 2. So the degree of the numerator should be 1, and that's going to look like slope-intercept form, like mx plus b. So we're going to use bx plus c. Degree 1, degree 0. Degree 2, this has degree 1. Okay, so if it's quadratic down here, you need to have a linear piece up here. That's where it gets, like I said, it's getting more steps here. You know, there's more stuff going on. All right. Then multiply out the missing pieces. So what does A get multiplied by? Yeah, that x squared plus 1x plus 1. And then bx plus c gets multiplied by x minus 1. So, yes, a little bit more. Because you got to multiply out a polynomial now. First one's not too bad. It's just distributive properties. So it's just going to put an A on all that stuff. All right? That's ax squared plus ax plus 1a. Then when I multiply bx plus c times x minus 1, that's going to be bx squared minus 1bx plus cx minus c. A little bit more complicated here. And I'm going to go ahead and what's my numerator from the beginning? The numerator was 3x minus 5. So look at what kind of terms I have in this blue line right here. I've got ax squared, I've got a bx squared. So those, for the x squared parts, it's going to be a plus b. What should that be equal to? What's x squared in the numerator? Is there an x squared? No, so it's going to be 0. And then for the x equation, now this one should be equal to what? 3, because there's a plain 3x, or there's a 3x in there in the numerator. So let's look at the things in our multiplied out part here that have a plain x. I've got ax minus bx plus cx. So that's going to be a minus b plus c. And then our numbers should add up to be -5. So I've got a minus c. No b in there. It's got a plain number on this that doesn't have an x or an x squared. So we have a system of equations now that's 3 variables. So it should be a 3x4 matrix that we're solving out of that. Is what we're going to end up finding here.
What you fill in for the missing?
Yes, anything that's not there is going to be a 0. So your first line in your matrix should be 1, 1, 0, 0. Then you got 1, -1, 1, 3. And then you have 1, 0, -1, -5. And find your values for that matrix. So 1, 1, 0, 0, 1, -1, 1, 3, 1, 0, -1, -5. So through RREF, it's A, B, and C. If it gives you decimals as an answer, change them to fractions. Just hit math, enter, enter. Make sure you change them to fractions. So hit math, enter, enter. That should be right. -2, you may have a sign in your matrix wrong or something. How are you going to know if you didn't get them right? Well, here A and B should add together to be 0, so they should be opposites of one another. So that's one way to kind of quickly tell if you got it right or not. Then A minus C should be -5 out of that. So now that creates a little bit of a problem because we got fractions inside of fractions, and we'll fix that in just a second. So let's start by just replacing our decomposition template with the pieces that go there. So you're going to have the -2/3 over x minus 1, and then we have 2/3 x plus 13 over 3 over the x squared plus x plus 1. Now that form is not generally not accepted in mathematical circles. So we want to fix it. The good thing is that they all have the same denominator in that, and that allows you to go -2 over 3 parentheses x minus 1 plus 2x plus 13 over 3 parentheses x squared plus x plus 1. And you could stop there. You don't have to multiply that 3 out on the denominator. So the denominator of the fraction that's in the top just comes down to the bottom is all that happens there. It's not anything. If these didn't have the same denominator, you'd get a common denominator between those two fractions and bring that down to the bottom. And the numerators would change a little bit. That doesn't happen a ton, but it does happen some enough that I need to show you one for sure like that. Okay. A little bit more complicated that time. A lot more going on. Let's go to one that's not more complicated than that one, but it's a different kind of something going on with it that we've got to take into account. All right, so they've got, what letter are we on? D. We're going to decompose x plus 2 over x cubed minus 2x squared plus x. So with that one, degree stuff is okay. Numerator is smaller than the denominator. Let's factor that denominator. What's the first thing that happens down there? Pull an x out, so GCF of an x, good. That's only if it's x squared minus 2x squared, or 2x plus 1. Will that trinomial factor? Multiply to be 1, add to be -2. -1 and -1. So that means we have x and x minus 1 and another x minus 1, which would be x minus 1 squared. So there's the factored form of the denominator. So instead of having a trinomial in there, we've got another linear piece, but it's squared, so that makes it a little bit different. Okay. Now, the way you've got to do your decomposition template for there, you start with the first factor is x. It's got a degree of what? 1. So you put an a over that. Then, here's where it changes because of the same factor happening twice. We've got to put a representative for each occurrence of that. Okay, so the first occurrence is just x minus 1. It would have a b over the top of it. Then it shows up as x minus the second occurrence, when the one that's the second part. It still has a degree, that this piece still has a degree 1, so you still put a c over the top of that. If it were to x to the third power, you would have x minus 1 to the third power. You would have another fraction that have x minus 1 to the third with a d over the top of that. So whatever that exponent is on the outside, you kind of build up to it with that linear term. Okay. Now, this makes finding the common denominator stuff a little bit more complicated because you've got 3 pieces to deal with. So when you look at that first fraction, what's missing from the x on the bottom? X minus 1 squared. So it's a times x minus 1 squared. The second one is missing what? An x and another x minus 1, because it only has one x minus 1 on it. And then the last one is just missing the x, so that one's actually not too bad. First two are a little bit more complicated. But look at your original fraction where you got it factored. This had the x, this wasn't there, so that's what got multiplied times a. This had the had one of the x minus 1s. There were 2 of them to begin with, and it didn't have the x, so that's this x, and then this is the other x minus 1. And this fraction had x minus 1 squared. It just needed that guy. That's how we're getting that. Okay. Now the algebra 1s part, multiplying that junk out. All right. So let's multiply that junk out. So that'd be, this turns into x squared minus 2x plus 1. And we're multiplying a to that. So that's going to be ax squared minus 2ax plus 1a. bx squared minus bx plus cx. So I've now multiplied all of that stuff out. My original numerator was little old x plus 2. If I look at what kind of terms I have here, that tells me how many equations I've got. I've got terms that have x squared. That's one equation. A plain x, and then plain numbers like 1a, 1a there. That's nice. So x squared is going to be a plus b, and it should be equal to what? 0. Plain x, negative 2a minus b plus c, and that should be equal to what? 1, because that's what's in front of x. And then our numbers, we got 1a. There's no other plain ones. That's nice, because that means a equals 2. And if a equals 2, what does b have to equal? Yeah. And if I've already got both of those, I can just plug in right here and get c. So That'd be -4 plus 2 would be -2, add 2 to that. So C would be 3 out of that. You can do that with the matrix if you want to. You know, your matrix would be 1, 1, 0, 0, -2, -1, 1, 1, and then 1, 0, 0, 2. And do RREF, and you get those same answers. I'm just doing it with, hey, they gave me A already, so I could kind of shortcut a little bit quicker on that just by back substituting. Okay, so that's nice. So I could go straight to my template here. A is over X, so that'd be 2 over X plus -2 over X minus 1 plus 3 over X minus 1 squared. No fractions involved, no fixing that needs to be done. That's my decomposed fraction there. Not too bad. Not too bad at all. All right. Let's look at another one. We're on E. All right. Just a couple more, and we're done for the day. All right. So let's start with this one. X to the third minus 8 over X squared, parentheses, X minus 1 cubed. All right. So first thing we need to check is the degree. The degree of the numerator is 3. What's the degree of the denominator? 5. Got X squared and X cubed. So that multiplying those together gets us X to the 5th at some point. So now the great thing about this one is it's already been factored for us. We didn't have to multiply it out. Or we didn't have to factor it ourselves. It was already factored, which shortcuts us a little bit so that we could go straight to our decomposition template, which is a little bit more complicated on this one because you have X to the second power and you have X minus 1 to the third power. So you're going to have more fractions involved with this one because you're going to have a fraction for plain X. And then you're going to have a fraction for the X squared. And then you're going to have a fraction for X minus 1. And then a fraction for X minus 1 squared. And then you're going to have a fraction for X minus 1 to the third power. We had to build up to each one. X squared, you got to build it with an X and an X squared. X minus 1 to the third, you got to have an X minus 1, then you got to have it squared, then you got to have it to the third. If it was to the fourth power, you had to have another one. Okay. So that's where this gets a little bit long and fun, I guess. Fun is the way I describe this, okay? So, what's A missing? An X and an X minus 1 to the third. That one's going to be a lot of work. No question. What's B missing? X minus 1 to the third, okay? What's C missing? What's D missing? It doesn't have an X squared. And then 1X minus 1. And then E is just missing the X squared. Get to the last one. That's the simplest one we've got. Okay. All right, so here we got X. So we needed another X. So that's this guy. And we needed the X minus 1 cubed. That's that stuff. Okay. B had X squared. So we don't need this. We need that. That's where that's going. C had one of those and none of those. So it got an X squared and then an X minus 1 squared to make 3. And then D had 2 of those. So I needed one more and the X squared. So that's that part. E had 3 of those. So it just needed that part. And so that's how you're building that. Now we need to do some multiplication. So maybe somewhere on scratch paper or something, I want to figure out what x minus 1 to the third power is, because I might have to use that twice. And I also need to know what x minus 1 squared is, because I'm going to have to use that. The rest of it I think we can do. Okay, so x minus 1 squared would be x squared minus 2x plus 1. X minus 1 to the third is going to take that answer and multiply it times x minus 1 again, which would be x cubed minus 2x squared plus x minus x squared plus 2x minus 1, which simplifies a little bit. Get that down, so simplify that as the x cubed minus 3x squared plus 3x minus 1. All right. Check my math, folks. Make sure it's right. I think it is. All right. So that you having those things handy are going to help us in multiplying this stuff out. Well, you're going to add an a and an x, all that. So because it's ax times x minus 1 cubed. So that ends up being ax to the fourth minus 3a x to the third plus 3ax squared minus ax. That's just that part. Okay. Now, the second part, that is just adding a b to all of that. That's bx to the third minus 3bx squared plus 3bx minus b. Okay. A cx squared, yes, that's right. I wasn't even touching the screen. It's not doing it now, so I don't know what happened. Got stuck. All right, so dx or cx squared times. Yeah, so I'm going to just cx to the fourth and then the last one's, all right, so we got dx. Do what now? 1b, sorry. So dx to the third minus dx squared and then plus ex squared. So the dx, this part here is dx to the third minus dx squared. That b right there is 1b. So we're going to have an x to the fourth equation. We're going to have an x to the third equation. We're going to have an x to the second equation, and an x to the first equation, and then we're going to have plain numbers. A lot of equations. But this actually works out pretty nice. X to the fourth power, there's only, how many of those are there? 2. There's an a and a plus c. So a plus, I'm gonna, you got to have kind of forethought here about how many letters you're going to have. A plus c should equal, how many x to the fourth are there in the numerator? None. So those should add up to be 0. So that tells us that these two are going to be opposites of one another. We already know that. Then we got an x cubed. That should be equal to 1 at the end. So let's get our x cubed pieces. We got a negative 3a plus b minus 2c plus d should be equal to 1. Right? And let's get our x squared equation. We got 3a minus 3b plus c minus d plus e is equal to, how many x squareds are in the numerator? In the numerator. Doesn't matter about the denominator anymore. None, so it's a 0. Plain x's. Negative a, 3b. That's it, right? How many plain x's are in the numerator? None, so it's equal to 0 again. And then we have the numbers. There's only one piece that's plain. That's negative b. And what's the plain number in the numerator? Negative 8. So that tells us that b is equal to 8, right? If b is equal to 8, then 3 times 8 is 24. A would have to be 24. Because negative a plus 24 is 0, so that's a. You can do this with the matrix if you want to. I'm just trying to do it without one just because to me it's a challenge. And then if a is 24, c would be negative 24. We already said those are opposites of one another. And so that we could plug that into the x cubed equation. Find out that d is, see, that'd be, a is 24. B is 8. C is negative 24. D is 17. And E is negative 7. Do it with a matrix. I'm doing it without one. No. C. A plus C is the first equation. And they equal 0, so they're opposite one another. Now all we got to do is just replace A, B, C, D, and E in our template, which is the easy part. Once you get the matrix, once you get this system of equations, put it in a matrix, RREF, then it's easy. From there, it's easy. The hard part is the algebra that gets you there. Okay, so that's going to be 24 over x, 8 over x squared, negative 24 over x minus 1, 17 over x minus 1 squared, negative 7 over x minus 1 to the third. Fancy. Now, what good is this? Not much for you in algebra, but if you go to calculus, if you can take a really big fraction and you're doing a derivative of it or you're doing an integration on it, which is things you do in calculus, big fraction, tough to do that with, but with the way you could decompose that fraction, this is much, much easier to do. It's easier to do 1, 2, 3, 4, 5 of them separately than it is to do that one all together, just based on the rules of calculus. So that's where this application or where this can make things better for you. And that's we're trying to prepare you for what's next. All right, last one. X to the third plus x squared over x squared plus 4 to the second power. Oh yeah, this one's short. All right. So does x squared plus 4 factor?
No, it's x squared minus.
X squared minus 4 would factor, but plus 4 does not. So that's not going to factor any further. So you can go to your decomposition template, which would be ax plus b over x squared plus 4 plus, now the second occurrence of that factor, cx plus d. And it all, this, yes ma'am?
Why did you put AX plus 3 on top?
Because this has a degree of 2. So this has to have a degree of 1. So that's where your like slope-intercept form comes from. So if this has a degree of 2, this has to be a degree of 1. If that factor is a degree of 2. Okay? Now, what's the AX plus B missing?
The squared.
Yeah, the X squared plus 4 again. What's the CX plus D missing? Nothing. That's nice. Yes, very much so, because I don't have to do any multiplication then. Wait till you get to the ones that go to H. All right, so we're multiplying out. AX times x squared would be AX to the third plus 4AX plus BX squared plus 4B. And then the CX plus D just copies down. So we're going to have an equation or system of equations. Set them up. X cubes, A, and nobody else is equal to 1. Hey, we already have the answer for A. And then x squared, hey, there's only one of those. It's B. How many x squareds are in the numerator? 1. And then we have the plain x's. We have 4A and C. There are none of those. And then the numbers, we have 4B and D. And there are none of those. Yeah, we already have A is 1. B is 1.
C is negative 4.
C would be negative 4. Good job.
B would be negative. Yeah, D would be negative.
D would also equal negative 4. Good job. All right. Now we just fill in our template based on that. So we have x plus 1 over x squared plus 4 plus negative 4x minus 4 over x squared plus 4 squared. Like I said, that one's short. It looks really rough at the beginning. But once you do your multiplication, set up your system, it works out really, really nicely. Uh-huh.
I wonder how long it takes us to go through Z.
13 through 46 are going to be a lot like what we've done here. On 47 through 54, those problems you're going to have to do long division first. So make sure I separated that, but so that you would know, hey, I need to make sure I get to those at some point. Work day on Monday, quiz on Tuesday. All right. Today is Friday.
I'm sort of glad we already went over this.